Building a PC for video editing requires careful consideration of various components to ensure smooth performance, fast rendering times, and the ability to handle high-resolution footage. This video will answer the question. What should you consider when building a PC for video editing? Processor, CPU, core count and threads. Video editing software like Adobe Premiere Pro, DaVinci Resolve, and Final Cut Pro benefits greatly from multi-core processors. Look for CPUs with at least 6 to 8 cores, though 12 or more cores are ideal for faster rendering and smoother timeline playback. Higher clock speeds translate to faster performance in tasks like scrubbing through timelines and rendering. Aim for a CPU with a clock speed of 3.5 GHz or higher. Both AMD Ryzen and Intel Core Series CPUs are excellent choices, but AMD's Ryzen 9 or Threadripper series offer more cores at competitive prices, which can be beneficial for heavy editing and rendering tasks. Graphics card, GPU. CUDA cores versus stream processors. If you're using software that leverages GPU acceleration, Brave. Elevate your videos with EditingMachine.ai, the world's first next-gen hybrid editing service. Fast, precise, and creatively crafted. Revolutionize your content today with Editing Machine AI. Adobe Premiere Pro with CUDA, a powerful GPU, is crucial. NVIDIA cards, especially those with a high number of CUDA cores like the RTX series, are favored for GPU-accelerated tasks. The amount of VRAM is essential for handling high-resolution video, 4K, 6K, or 8K. Aim for at least 8 GB of VRAM, but 10 GB or more is recommended for 4K and higher resolutions. While NVIDIA is often preferred for CUDA acceleration, AMD GPUs also offer excellent performance, especially with software that supports OpenCL or Metal. Memory, RAM. Video editing is memory-intensive, especially when working with high-resolution files and multiple layers. At least 32 GB of RAM is recommended, though 64 GB or more is ideal for handling larger projects and smoother multitasking. RAM speed also matters, especially with modern CPUs that benefit from faster memory. Look for RAM with speeds of at least 3000 MHz or higher. Storage. Solid-state drives, SSDs, are a must for fast boot times, quick access to software, and speedy file transfers. A high-capacity NVMe SSD, 1 TB or more, is ideal for your operating system, software, and active projects. While SSDs are preferred for speed, you may also want a larger HDD, 2 TB or more, for storing completed projects and backup footage. Consider RAID setups for redundancy and performance if your budget allows. A separate SSD dedicated as a scratch disk can significantly improve performance when working with large projects. This drive will handle temporary files and media cache. Motherboard. Ensure your motherboard is compatible with your CPU and has enough PCIe slots for future upgrades, such as additional GPUs, SSDs, or capture cards. If you plan to add more storage, a second GPU, or specialized hardware like a capture card, make sure your motherboard has enough expansion slots. For faster data transfers, especially with external drives and peripherals, look for motherboards with USB 3.2, Thunderbolt, or USB-C ports. Power supply unit, PSU. Reliable power supply with sufficient wattage is crucial. For a mid to high-end build, 750W to 1000W PSU should suffice, especially if you're using a powerful GPU and multiple drives. A PSU with an 80+ gold or platinum rating ensures efficiency and reliability, reducing the risk of power issues during intensive editing sessions. Cooling system. Video editing can push your CPU to its limits, so a good cooling solution is essential. Consider a high-quality air cooler or a liquid cooling system, especially for high core count processors. Ensure your case has adequate airflow with multiple fans to keep your system cool, especially during long editing sessions. Monitor. For video editing, a high-resolution monitor, 4K or higher, with good color accuracy, 100% sRGB or Adobe RGB coverage is essential. IPS panels are preferred for better color reproduction. A dual or even triple monitor setup can enhance productivity, allowing you to keep timelines, footage, and tools on separate screens. Peripherals. Invest in a high-quality mouse and keyboard, preferably ones designed for comfort and precision. Editing specific devices like control surfaces, e.g. Elgato Stream Deck, Lupodeck, can speed up your workflow. External storage, fast external drives, preferably SSDs with USB 3.2 or Thunderbolt, are useful for backup, transporting projects, and working on the go. Operating system and software. Ensure your chosen software works well with your operating system. Windows and macOS are the primary choices, with Windows offering more flexibility in hardware configurations. Make sure your software is optimized for your hardware. Some programs perform better with specific CPUs or GPUs, so research the best combinations for your editing software. Budget considerations. Distribute your budget wisely. While it's tempting to splurge on a top-tier GPU, balance spending across all components to avoid bottlenecks. Consider your future needs. Investing in slightly better components now can save money down the line when you don't need to upgrade as soon. Backup and redundancy.
For data safety, consider setting up a RAID configuration. RAID 1, mirroring, or RAID 5, striping with parity, can provide redundancy, protecting your work from drive failures.
In addition to physical drives, using a cloud backup service ensures your projects are safe and accessible from anywhere. The hidden performance killer. Sometimes people spend a lot on their dream video editing PC, only to find it slower than expected. The culprit is often bottlenecking, a critical issue when building a system. What is bottlenecking? Bottlenecking happens when one component, like the CPU or GPU, limits the performance of other parts. Even with a top-tier GPU, a weak CPU can slow down your PC. This mismatch causes one component to bottleneck the other, reducing overall performance. How bottlenecking affects video editing. In video editing, bottlenecking can lead to slow rendering. A weak CPU can slow down render times, even if you have a strong GPU. An underpowered CPU may struggle with smooth playback, especially with high-res footage. A bottlenecked system can have difficulty running multiple apps at once. Examples of bottleneck scenarios. Pairing an NVIDIA RTX 3080 with an Intel Core i5-10400. The powerful RTX 3080 is held back by the mid-range CPU, resulting in slow rendering and underutilized GPU power. Pairing an Intel Core i9 13th generation with a GTX 1650. The strong CPU is limited by the weak GPU, leading to slow GPU tasks like real-time playback. Using 8GB of RAM with a Ryzen 9 5950X and RTX 3070. Limited RAM creates a bottleneck, especially with large video files, slowing the system despite powerful CPU and GPU, avoiding bottleneck issues to avoid bottlenecking. For example, an RTX 3070 pairs well with an Intel Core i7 and 12700K. Use bottleneck calculators. These tools help estimate potential bottlenecks between components. Consider your workload. Prioritize the CPU for heavy rendering or the GPU for effects and 3D work. When building a PC for video editing, prioritize a balanced configuration that meets your specific needs, whether it's 1080p, 4K, or even 8K editing. Ensuring compatibility, reliability, and performance across all components will lead to a smooth editing experience and faster project turnarounds. Happy building! If you found this guide helpful, hit the like button and subscribe to Tech Arena for more tips and tricks.